Okay, so we already spent some time last week looking at finding exact values of trig functions, specifically sine and cosine, but we haven't done anything with tangent yet. The good news is that everything that we did for sine and cosine is going to work for tangent as well. The bad news is that there's going to be a few extra steps at the end that we didn't have to do with sine and cosine, but that's no problem. So first things first, we know we have to draw the angle, and in this case our angle is 240 degrees. So, since I'm in degrees, I know that 0 degrees is over here, 90 degrees is up here, 180 is over here, 270, and then back to 360 for a full trip around the circle. In this case, we have 240, so I go around to 180, and I know I need 60 more degrees past 180. So if I draw this line down here, I know this has to be a 60-degree angle because I'm taking 180 and I'm going 60 more. The second thing I do is I draw my triangle. And you know that we always draw our triangles using the x-axis, so I'm going to go up here. I know this is a right angle, and now I have a triangle that I can use for trigonometry. Okay, the third thing I do is I label my triangle. Now, if you go back to last week and you think about the 30, 60, 90s that we worked with, we always know when we're on the unit circle, which in this case we are, that any radius is a length of 1, because any radius in a circle is the same length. And I know that this point over here is the point 1, 0 on the unit circle. When my hypotenuse is 1, to find my shortest side, which is across from the 30-degree angle, I take my hypotenuse and I cut it in half. So this here is going to be a 1/2, but I have to make it negative because I'm going from the origin to the left. And then to get the middle side, I take the shortest side and multiply it by radical 3. So 1/2 times radical 3 over 1 would be radical 3 over 2. And in this case, again, because I'm going down, I have negative radical 3 over 2. So what is tangent? Tangent is always opposite over adjacent. When you think of TOA, T-O-A, tangent's opposite over adjacent. So what I need to do here is I need to figure out, okay, which of these things is opposite, which is adjacent? Well, opposite or adjacent of what? Remember that this 60-degree angle is the angle in question. So opposite of the 60-degree angle is going to be radical 3 over 2. Negative radical 3 over 2. Sorry about that. So my opposite is negative radical 3 over 2. That's my opposite. Divided by my adjacent, which is negative 1/2. Now the easy part with sine and cosine is that that denominator was always 1. And we know any number divided by 1 is just itself. Well, unfortunately, when we're dealing with tangent, the hypotenuse doesn't come into play, so we don't get to use 1. So, here's how we finish this. Little side example. If I were to ask you, what's 1/2 times, I don't know, random number 3/4? I'm sorry, divided by. 1/2 divided by 3/4. How would we figure that out? Well, one thing you need to remember as far as fractions go is I can change division to multiplication as long as I use the reciprocal of the second fraction, meaning I take the fraction and flip it upside down. Once I've done that, once I've changed it to multiplication, now I can reduce numerator and denominator. 2 would go into 2 once, 2 would go into 4 twice. I multiply straight across and I end up with 2/3. Now keep in mind this was just a side example. It had nothing to do with this problem, but it's a refresher as to how we do division of fractions. And that's really what we have here. Okay? Really what we have is we have negative radical 3 over 2 divided by negative 1/2, if I kind of write it out that way. So to change division to multiplication, I just simply make this multiplication and I flip this fraction upside down and make it negative 2 over 1. Now that I've done that, let's do a little reducing. 2 goes into 2 once, 2 goes into 2 once. And when I multiply straight across, in the numerator I have negative square root of 3 times negative 1. That's a positive square root of 3. The denominator is 1 times 1, which is just 1. So the tangent of 240 degrees is equal to radical 3. Let's do another one of these. What if I throw this thing at you in radians? Okay, well, it's your call as far as how you want to go about radians. Some people are comfortable in radians and can just say, you know what, I'm going to do 15 divided by 4. 4 goes into 15 3 times. 3 times 4 is 12. Subtract down, that's a remainder of 3. So I want to do 3 3/4 pi for my angle. Others may look at that and go, you know what, I'm not a big fan of radians, so I'm going to convert. So when I do 15 pi over 4 times 180 degrees over pi, that's my conversion, because radians, pi's cancel. So you grab your calculator, you say, okay, what's 15 times 180 equals, divide that by 4, and you're left with 675 degrees. Now I know that when I start at 0 and I go all the way around one time around the unit circle, that's 360 degrees. So I would probably just subtract 360 from this. You know, subtract off 360 degrees. That leaves you with 315, so that's really the angle that you're graphing. You know, the same kind of goes for 3 3/4 pi. Well, I know that one time around the circle is 2 pi. So if I subtract 2 pi from that, really the angle that I'm graphing is 1 pi. Or 1 3/4 pi, sorry about that. 3 3/4 minus 2 would be 1 3/4 pi's. Okay? Either way, whether you choose to graph this in degrees or in radians, we're starting over here where we always start. 315 degrees would be, let's see, this is 90, 180, 270. I need 45 more degrees, so I'm going to split this thing right in half, and I know each of these are 45 degrees. Run this thing right up here, right triangle, and I'm ready to work. If you think of this as radians, remember, this is 1 pi, so this would be 1/4, 2/4, 3/4 would be right there. So it's up to you which way you decide you want to graph that. But you can graph it and get the same thing in degrees or in radians. Okay? So now this just becomes, you know, once we get the angle graphed and we get the triangle drawn, I know that this is 1 because we're on the unit circle. And I know to get my shorter sides, we did this a bunch. You probably already had this memorized. Each of these sides is going to be radical 2 over 2. But one of these, this one, is going to be negative because I'm going down from the axis. Okay? So we know tangent is opposite over hypotenuse. So the tangent of 15 pi over 4 is equal to negative radical 2 over 2 divided by positive radical 2 over 2. Remember, we can change division to multiplication by using the reciprocal of the second fraction. So I flip that one over. Don't flip both of them or else it's not doing us any good. So this, we got a bunch canceling here. We got this 2 and this 2 canceling. We also got this radical 2 and this radical 2. All we're left with is negative 1 over 1. So the tangent of the angle 15 pi over 4 is just equal to negative 1.